All right, let's do another example. Again, I'm going to read this one. Again, take notes, but I'm going to read the problem and then we'll start to working out the different parts of it. So it says, on January 1st, 2010, the population of California was approximately 37.3 million people. On January 1st, 2019, the population was 40.0 million people. Let t equal 0 represent year 2010. Says, so that's the information we're going to get. Okay, so let's write that down. Okay, so we've got 2010, right? And this is all California population in the millions. 2010 population was 37.3 million. In 2019, the population was 40.0 million. And they say, okay, why not, right? The initial value of the year, or no, that's the population, hold on. T. So let t equal to 0 represent year 2010, which means that every year after this is telling you how many years after 2010, right? So 2011 would be t equal to 1. 2012, t equal to 2, and so on, okay? Now, what else? Okay, so now here's what they want. So here's A. So A says, write a function defined by p of t is equal to p naught e to the kt power. All right, so something like that. Okay, so they want us to do, it says to represent the population of California in the millions and for t years after 2010. Okay, so now that's basically we're going to take this information here and plug it in here. So that means what? The initial population is going to be the 2010 population. Well, that's all we can fill in right now. So it's going to be P of t is equal to 37.3 e to the kt, right? But we don't know what the constant is, okay? So we know what P naught is going to be, but we don't know what the constant is going to be. So let's solve for the constant. So let's use the information here to solve for K, okay? So how are we going to do that? Well, let's plug in the values, the 2 points that we have. We know this point at t equals 0, and we know this point at t equal to 9, right? 2019 is 9 years later, right? So we have 2 points that we could put in. So let's put in the information. So that means the ending amount we know is 40.0, and we know how much time had passed. We know that that was 9 years. So k times 9, okay? Or we could more appropriately write 9 times k. That's the power. Okay, now, guess what? Now we're going to solve using what we've been doing. So we're going to divide both sides by 37.3. So we're going to get 40.0 divided by 37.3, right? And then we're going to take the natural log of both sides, right? So we're going to get natural log of this is going to equal the natural log of this. But again, the natural log and the e will cancel out, and we get 9k. And then all we have to do is divide both sides by 9, and we get our k value. All right, so now we can stick this in for k. Now we can get the exact answer, right? We can approximate k if we want, or we can just stick this in to our final answer, okay? Depends on what the problem wants us to do, okay? So here's what I will do. Let's write it down here. So A, let's write A over here. So the answer to A is going to be what? P of t is equal to 37.3 times e raised to the what? Our k value is going to be, so it's going to be t, so let's put our variable t, and it's going to be times the natural log of 40.0 divided by 37.3, okay, divided by 9. Okay. Now, if we wanted to approximate the k value out to whatever 4 decimal places or whatever, that's fine. But you could also leave it like this. Okay. Let's see here. Now, it says predict the population 2025, round to 1 decimal place. All right, let's do that because, and it makes sense because we're dealing with 1 decimal place, and these are in the millions, right? So we're going to round to the nearest 100,000 people, it looks like. So let's see here. Okay, so now this is part B, right? Part B is that they want us to estimate 2025 population. So we want to know the population in 2025 for California. Okay, so we're going to use the model that we just created in part A to do that. So let's do this. So we're going to do E and so 2020, one thing we have to do is 2025, right? How many years after 2010 is 2025? That's 15 years, right? So T equals 15, right? All right, so that's important to know. So we're going to do 15 times the natural log of 40.0 divided by 37.3. We're going to divide that by 9. Okay, and we're going to multiply by, so this part here, this whole part gives us approximately 1.1235, but I'm going to leave it in the calculator. So now I'm going to multiply that by 37.3. 37.3, and we get 41.9 million people, rounding to the nearest tenth. So 41.9, so this gives us approximately, so P of 19, or excuse me, P of 15, right? So P of 15 is approximately equal to 41 point, was it 9? Yeah, 41.9 million people. All right, so now part C says determine the year the population of California will double what it was in 2010. All right, so now, so we know in 2010 it was 37.3. So we want to know, hey, in what year will the population double? So that means in what year will the population reach what? 74.6 million, okay? So now we want to know, hey, how much time will pass in order for the population to equal what? 74.6 million. All right, so let's do that. Okay, so it's going to be similar to part A, but we're just solving for a different variable. Okay, so now we want P of t to be 74.6, so 74.6 is going to equal 37.3 e to the what? Well, now we have our k value, right? So now we're going to solve for t. So we know that this is the natural log of 40.0 divided by 37.3 divided by 9, and we've got over here, we've got t. So we're solving for t now. Okay? So now what we're going to do is we're going to divide both sides by 37.3. Okay? Okay? And then that means this is going to go away because it becomes 1. Right? And now we're going to take the natural log of both sides. So we're going to take the natural log of 74.6 over 37.3 is equal to the natural log of this, okay? So what I got here is I got e to the natural log of 40 divided by 37.3, all divided by 9 times t. And again, this is going to cancel each other out, and we're going to get the exponent out. So what happens to this? This becomes the natural log of 74.6 over 37.3 is equal to the natural log of 40 divided by 37.3, all divided by 9 times t. And now I can multiply both sides by 9, so I'm going to put 9 over here and get rid of this. And now I can just divide both sides by this natural log. Right? And that gives me t. Okay, so now all I have to do is put this in the calculator. Now again, be careful how you put this in the calculator. It's easy to make a mistake if you're not careful. Okay, so I'm going to do this natural log, multiply by 9, and then divide by this natural log. So let's see, so natural log of 74.6 divided by 37.3, and then I'm going to multiply that by 9, and I'm going to take that entire thing and I'm going to divide by the natural log of 40.0 divided by 37.3. All right, so now I'm going to hit equals. All right, so what's the question we wanted to ask? It says determine the year the population of California will double what it was in 2010. Okay, so now this is what we got for t, right? So t, what I got for t was I got approximately equal to, where is it? 89.3 years. 89.3 years. Now, what does this mean? Okay, this means that approximately 89.3 years, so within the, so 89.3 years after 2010, right? So now, so if we take 89 years from 2010, that's what? 2099, right? But it's between 2099 and 2100. So it's in the 2099th year. It's in that year, okay? So because of the fraction. So we know it is in the year 2099 that the population of California is predicted to double based on this model. Okay, so 2099 is the year. All right, that's it.